All right, kiddos, we're talking about limits that go towards infinity. And so remember that I told you there are three kinds of limits on the AP test. There are derivative limits that we'll learn about in a couple weeks, not a couple weeks, a week. There are limits that, that involve infinity in some way that are asking about asymptotes. And then the third kind of limit is this kind of limit where they're asking us to compare rates of change and talk about what's happening with that function that they gave us. And these are almost always, again, fractions. Now, to understand what we're going to do with this, though, we have these four functions graphed in front of you. And the point of this is to see what happens when these functions go towards infinity. So you can see as they go towards infinity, all of these functions will increase infinitely. Their y values will all increase to infinity, all of them. But they increase at different rates. So the fastest rate of increase is the 2 to the x, which is right here. Exponential functions increase about as fast as anything does. They increase pretty rapidly. The second fastest rate of increase is our parabola, which is this guy right here, x squared. The third fastest rate of increase is your line, which is x. And then this function right here is natural log of x. And it increases to infinity. Its y values will get bigger and bigger forever, but it increases at a much slower rate than any of these. Okay, so this is ln of x. So here's the deal. If you are presented with the limit as x goes to infinity or negative infinity of something that is a fraction, okay, like this, what you do is you compare the rate of change on top to the rate of change on bottom. Because if the rate of change on the bottom of the function is more rapid than the rate of change on the top, what's going to happen is you'll have a number divided by infinity. And numbers that are divided by infinity, if you divide something infinitely, we just say, well, that goes to 0, right? We're going to divide something to an infinite number of pieces. Well, that's about as close to 0 as you can get. So if you look at this, the limit as x approaches infinity of 1 over x, now don't do this because it's not real math, but if I plug in the infinity, that's 1 over infinity. And what's 1 divided by, 100,000? It's almost 0. What's 1 divided by 10 million? Almost 0. And so what we do is we just go ahead and say that that's 0. On the other hand, if you have infinity on the top of your fraction and a number or something else on the bottom, so if the rate of change on the top is faster, then you're going towards infinity. So in this case, I have infinity divided by 2. Well, infinity divided by 2, I mean, that's the biggest number that we can think of divided by 2 is still a really big number, right? And so that's infinity. And so what this boils down to is that if the rate of change of the function on top is smaller than the rate of change of the function on bottom, you're going to 0. And if the rate of change of the function on top is bigger than the rate of change of the function on bottom, you're going to infinity. So I've got two sample problems from the work on the back of the worksheet for this. And if you look at this, and again, this is not real math, so don't write, well, I mean, you can write it out, but don't try to use this as justification on the AP test. But if you look at this, we're going x to infinity. If you plug in the infinities, I got infinity over infinity squared. Well, infinity squared is a whole bunch bigger than infinity. And that means that the rate of change on the bottom is bigger, is greater. Okay, and so this is going towards 0. Now you can also see this on the graph on the front of your paper. If you look at x, there's our rate of change for x. And if you look at x squared, here's the rate of change for x squared. X squared is increasing a lot faster. Okay, and since the faster rate of change is happening on the bottom of the fraction, we're going to go towards 0. Over here, if you look at this, we've got x over the natural log of x. Now this one is very helpful to look at that graph on the front of your paper for. Here is my x, and my rate of change, the rate at which we're going towards infinity, is pretty good. And if you look at this natural log of x, sure, our y values are increasing, but they are not going to infinity nearly as fast as x. And so the rate of change on top is much faster than the rate of change on bottom, and that means that the limit as x approaches infinity of this function is infinity. And so again, you're comparing the rate of change on the top of the fraction to the rate of change on the bottom of the fraction. If the bottom is bigger, we're going to 0. If the top is bigger, you're going to infinity.